right, today we're going to do a little binomial expansion, okay? And there's this little thing right here we're going to call Pascal's triangle. We can't see it, we're right. Pascal's triangle, famous mathematician. No, it's not Pascal from, hold on.
Tangled.
Yeah, no, it's not Pascal from Tangled, but he did get his name from a famous mathematician. Okay? So we're gonna build this right here. But by the way, you don't have to make cute little boxes, okay? Alright? So I want you guys right here. This is row 0, this is row 1, this is row 2. So we are gonna do what's called row 3. Okay? So you're gonna write this in your journal. Row 3, and then we'll put row 4 and 5 and 6 and 7 and 8. No, we're stopping. We're just gonna stop. Yes, it does continue. It does continue, but we will just stop at 8 and build this cute little triangle known as the Pascal triangle, not the Pascal from Tangled. Now, here's how it works. We have a 1, and there's a 1 and a 1. And 1 plus 1 is 2. Okay? You're going to put a 1 all the way down. But you don't worry. We're going to do it row by row. So right now, what is 1 plus 2? 1 plus 2 is 3. 2 plus 1 is 3. And then a 1. And then we're going to take the sum of these right here. And the sum of 1 and 3 is 4. The sum of 3 and 3 is 6. 3 and 1 is 4. And then we put a 1. Just so you know, 1s are going to be all the way down. And then we're going to add these together. And we're going to get a 10. Alright? Oh, my bad. Hold on. Sorry. 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. So we are, if you look at the pattern here, alright? 1 and 1 is 2. Then we have 1 and 2 are 3. 1 and 3 is 4. 1 and 4 is 5. 1 and 5 is 6. 5 and 10 is 15. 10 and 10 is 20. Then we have 15. Then we have 6. 7. 21. 35. 35. 21. 7. And last but not least, 1 plus 7 is 8. 7 plus 21. 28. 21 plus 35. 56. 35 plus 35. 70. 56. 28. And 8. And that's, we're going to go ahead and stop. That's what I want you to focus on putting into your journal nice and neat. Alright, now before we tackle this problem right here, okay, which is r minus t to the power of 4. That right here, that number lets us know which row we are dealing with. So what row would we be dealing with? Row 4. So we're going to try something a little bit easier. Alright? So what I'd like you to do is I would like you to do a plus b to the power of 4. Right? A plus b to the power of 4. And I want you to understand that we are going to take this row right here. We're going to write a 1. We're going to give a little bit of a space. Okay? We're going to put a 4. We're going to put a 6. We're going to put a 4. We're going to put a 1. Okay? So I want you to, that's what we're starting out with, right? We're just going to start out with 1, then we're going to start out with 4. I'm just going to be putting parentheses around this. Now, here's how it works, all right? I'm going to highlight 2 different colors. One of them is going to be in blue, and one of them is going to be in red. Okay? So here's what I'd like you to do. I would like you to put a to the 4th, and then I'd like you to put b to the 0, and then put a little plus right there. Then I'm going to do the next one. You're going to see if you can figure out the pattern that I'm doing. you'll notice with our powers, we started with a to the fourth and b to the 0. What's 4 plus 0? 4 plus 0 is 4. And then we have 3 and we have 1. 3 plus 1 is 4. So as these are descending, 4, 3, 2, 1, 0. The other ones are ascending, 0, 1, 2, 3, 4. Okay? So how do we know what power to start with? That number right there. So in the fourth row, you're going to start with a to the power of 4. Now what would our final answer be? If I took all of this and I just multiplied everything I need to multiply and add it together, here's what our final answer would be. It would be a to the 4. Because what is b to the power of 0? B to the power of 0 is 1. Any number to the power of 0 is 1. Then I would put plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the 4th. And that would be my final answer. Now that's not our final answer for our problem. I just tried to do something simple. Start with what? A plus b to the power of 4. Now what we're going to do is we're going to do our problem using not a and b. We're going to use r and a negative t. So we're going to use r and a negative t. Okay. All right. Here we go. I'm doing r minus t to the power of 4. I'm going to highlight this one in blue and this one in red. Okay. Give us a little bit of room here. I'm not going to recreate Pascal's triangle. All right. I already know I'm starting off with a 1. Right? And then what do we have next? We have a 4, and then we have a 6, a 4, and finally a 1. I'm just kind of giving myself some space here. So what are we going to start with? We have, I'm going to do parentheses. We're starting with r. And we're doing it at the power of 4. And that's a 1. That's a 1. We're doing negative t to the power of 0. Then I'm going to put a plus. Right here, I'm going to do r to the power of 3 and negative t to the power of 1. Put a plus. I'm going to pause the video real quick to see if anybody has any questions so far. All right, here we go. I'm going to do r squared. I'm going to do negative t squared plus r to the first negative t to the power of 3 plus, and lastly we have r to the power of 0 and negative t to the power of 4. What do these exponents always have to add up to? They always have to add up to whatever that power is right there. Okay? So 4 and 0, 3 and 1, 2 and 2, 1 and 3, they all add to that number right there. So this is everything written out. Now we're just going to evaluate everything step by step. So here we go. Here's our final answer. I have a 1, I have an r to the 4th, and I have negative t to the 0. What is any power to, what's anything to 0 power? Nope, 1. So all I'm left with is just r to the 4th. Now, this is a 4. This is r cubed, but I have a negative t to the power of 1. So is that negative sign, is that going to impact this? It is, isn't it? So this is actually going to be minus 4r cubed t. r to the 4th minus 4r cubed t. Okay? Now this negative, what's going to happen to it? It's going to cancel because a negative times a negative is a positive. So this is going to be plus 6r squared t squared plus. This right here, there's one of these, there's 3 negatives. But a negative times a negative times a negative stays a negative. An odd number of negatives. Sure. If I have an even number of negatives, right, they turn to a positive. But if I have an odd number of negatives, they stay negative. Alright, so even cancels to a positive, odd stays negative. So I have to write here, I actually going to have to put a minus 4rt cubed because of that negative right there. And what's the last thing I'm going to do right here? I'm going to do a plus because there's an even number of negatives, all right? And that becomes a 1, so I'm just left with t to the power of 4. And that's what I'm actually going to type in carefully. All together. That's going to be my final answer. All right, here we go. I'm going to type in an r to the power of 4. Right arrow. All right, look back at it. Minus 4r to the power of 3, and then a t, and then we had a plus, correct? 6r squared, all right. 6r squared t squared minus 4r t to the power of 3, t cubed, then a plus, oh, not equals, plus t to the power of 4. There we go. Does that match up with everything we got? All right. Hey, good work. We got it done. Ooh, let's do one more. All right, let's just do one more here. Ooh, one bad mamma jamma right there. All right. So right here, what are we doing to the power of 3? So what I would do is I would just look at your row 3. You have a row 3 already written down. A 1, a 3, 3, and a 1. So all we're going to do right here is we're going to do 1, 3, 3, and a 1. I'll highlight what we have. Okay, the blue, that's the red. Okay. So I'm going to do open parentheses, and then I'll do a open parentheses. So we're going to put x, and we're going to raise it to the power of 3. We're going to put negative 1 over x to the power of 0. So this is going to be x squared. And this is going to be negative 1 over x. Not squared, sorry. Just the first. Because what do these exponents always have to add up to? They have to add up to 3. Parentheses. We have x to the first. We have negative 1 over x squared. And last but not least, we have x to the 0 and negative 1 over x to the power of 3. Alright, so right here, all of this right here, we'll just evaluate to x cubed, because that becomes a 1. There's a 1. Okay. And this one's going to be a little bit trickier, but plus, I have 3, I have an x squared, but what is that being multiplied by? A negative what? 1 over a negative 1 over x, correct? So what's going to happen this x right here, if I have x squared over a negative x, if I multiply those together, what happens? These cancel out, and you just have n. All you're left with is a negative x. I'm not sure what I just did there. I'll just do it right up here. All right? I have 3 over 1. That's what this is. Times an x squared over 1 times a negative 1 over n x. What does x squared actually mean? X times x. What can I cancel out? Those x's cancel out. And so all I'm left with now is a negative 3x. That's all I'm left with. So our final answer so far right now is x cubed minus a 3x, because that's the product of all of this. I'm going to put plus. Now over here we have plus a 3x times a positive 1 over x squared, because a negative 1 over x times a negative 1 over x becomes a positive 1 over x squared. So if I were to multiply it together, I'd have 3x over 1 times 1 over x squared. What's going to happen? That cancels out one of those. And so what am I left with? I'm actually left with a 3 over an x. That's what I'm left with. 3 over an x. And then over here, the last thing that I'm going to be left with is this right here just becomes a 1, but a negative times a negative times a negative stays a negative. So right here, I'm going to have a negative 1 over x cubed. So I'm just going to put minus 1 over x cubed. And that's going to be my final answer. X to the power of 3 minus 3x plus 3 over x as minus 1 over x cubed. All right, you know what? This one would probably be a good one last one to do right here, because now we have coefficients in front of it. So let's just do one more, and then we'll call it a day. Integers. All right, so we have 2 and a z, but 2z minus 3k to the power of 4. So once again, I'm going to the 4th row. Okay. So this right here, this is my row 4. So I'm going to put a 1. Then I'm going to put a 4. I'm going to put a 6. And a 4. And then finally a 1. I'm going to highlight my 2 numbers that I'm dealing with. 2z, negative 3k, we're going to be starting right here with 2z. We're going to raise that to the power of 4, and we're doing negative 3k to the power of 0. 2z cubed negative 3k to the first plus 2z squared 2z to the power of 3 and negative 3k to the first and last but not least 2z 0. I messed up here. I messed up. Sorry, I messed up here. That's supposed to be 1 and 3. It's supposed to be, the blues are supposed to be descending. My bad. They're supposed to be descending. The reds are supposed to be ascending. So 4 0, 3 1, 2 2, then 1 3, then 0, and finally 4. If I write everything out like this, if I make a mistake, I can usually catch myself if I'm writing things out. So the blue are descending, all right, and the red are ascending. Okay, and the sum of these are always going to equal whatever that power is. We're going to go ahead and just start off with the very first one. All right, so 2 to the power of 4 is 16. Okay, this is a 1, so our first number is going to be 16. That's our first coefficient. Z to the 4. Okay, then we're going to put a minus sign. And the reason we're putting a minus is there's definitely one negative in there. 2 times 2 times 2 is 8. All right, 8 times 4. All right, 32. And 32 times a negative 3. Is that negative 96? We'll just check, just to be sure. Ready? 4, parentheses, 2, to the power of 3, times negative 3. Negative 96. All right. Negative 96, we're going to put z cubed and then a k. Now, a negative times a negative is a positive. So, negative 3 times negative 3 is a 9. 2 times 2 is 4. Times a 6. So, what do we have to multiply together? 6 times 4 times 9. We're squaring the negative 3. 2 16, so put plus 2 16 z squared k squared. Okay. On this one, what did I multiply together? 4 times 8 times negative 3, which got us a negative 96. What do we multiply together here? We have 4 times a 2 to the first times a negative 3 times negative 3 times negative 3, which is negative 27. So 8 times negative 27. Gets us all the way to another O. So we have z to the first and k to the power of 3. And finally, at the end, we're going to have negative 3 times negative 3 all the way to the power of 4. That's going to get us a total of 81. So plus 81 k to the 4. And there's your final answer. Sorry? No. These aren't the same. That's a positive 216 z squared k squared. This is a negative 216 z k cubed. The only way they could cancel out is if these were the exact same powers. Okay. All right, so here we go. Let's go and type this in. Everybody, hopefully somebody has this down so I don't have to memorize it. 16. Is it z? Z to the fourth. Z to the fourth minus 96 z power of 3 k 216, and then we got a z squared k squared. Where is that? There we go. Minus 216 zk to the power of 3k cubed, then plus it, not equals, plus 81 k k to the power of 4. Alright, does everybody understand why we have a positive there at the very, very end? Because when you take a negative and multiply it to itself 4 times, it becomes a positive. Alright, there you go. I'm not going to do this one. Alright, but you should have 3 good, actually 4 examples. We start off with this one. Alright, I'm going to go ahead and end it right here with looking at Pascal's triangle. That right there is binomial expansion.